Okay, hey you guys. So the first thing that we're going to do is talk about just the basics of these problems. So we're going to talk about what's going on and how you can approach the problems that were on your homework last week and the problems that you're going to see again on your exam this week. If you already feel really comfortable with the mechanics of this stuff, feel free to just skip this and go on to the next ones where we talk about the problems themselves from the homework. If you feel shaky at all about these problems, or if you think you could just benefit from a refresher, then just hang out. We're going to talk about this for a few minutes and go over just the really bare bones stuff about these problems and make sure that we're really clear on the foundations so that we can go forward and do the harder stuff that's in the homework assignments and on your exam this week. Okay, so the first thing that we're going to do, we have two examples. So we're going to work through these slowly, but first I want to talk about what's happening in these problems. So what are we actually looking at here? So as you know, as we've talked about, the first few lines that we have that are all the way out to the side are our premises. And then at the bottom we have our conclusion. In between the premises and the conclusion, we have these indented lines. And those are our sub-premises. Those are the lines where we write down what the moves are or what the rules of deduction are that allow us to move from our premises to our conclusion. So I'm saying all these words that might not make literally any sense, which is totally okay. That's something that we went through really quickly in the videos and that your book just literally doesn't cover. So if you're confused about what's even happening to begin with, I totally get it. That makes sense. I'm going to talk about that just a little bit for the next few minutes. Okay, so here again we have the premises, we have our conclusion, and we have our sub-premises. In this argument, in this example, our premises are if P then Q, P or R, and not R, and our conclusion is Q. So that's in a normal proof, in a real proof, usually that's all you're given are your premises and your conclusion. And in a real argument that you encounter in the world, that's what you're given as well. You're given your premises and your conclusion. And it's up to you to make these steps of inference or these deductions on your own. So here what we're doing is we're saying here's the premises, here's the conclusion, and we're just writing out what the steps are or the deductions are that you have to make in order to get from your premises to your conclusion. So we can fill this in with some content to make this make a little bit more sense. So let's say that P stands for it's nice outside, Q stands for I'm going jogging, and R stands for it's raining. So here the premises would say if it's nice outside, then I'm going jogging. Either it's nice outside or it's raining, and it's not raining. Therefore, I'm going jogging. Okay, so in an argument, that's all you would get. You would get these premises, and you would get the conclusion. Now, I don't make explicit how we get from these premises to the conclusion. I don't say explicitly how we get from these facts, or I give you the conditions under which I go jogging, to the fact that I'm going jogging. We just know that when it's nice outside, I go jogging. We know that either it's nice outside or it's raining. And we know that it's not nice outside. And I'm telling you that I'm going jogging. Okay, so we can kind of see what steps you might have to take to get from these premises to the conclusion. And what we're doing, because it's school, so we make things, you have to fill out everything that you do, every step that you take and show your work. We're going to make you write out all of your sub-premises and cite the rules of deduction that you make to get from those premises to the conclusion. Okay, so here the kinds of steps that we're going to have to take are saying like, well, if it's not raining, that means that it must be nice outside. And I said that if it's nice outside, that I go jogging. And I said it's nice outside, so I'm going jogging. That's all that we're doing. It's really simple when we break it down and we can move through it kind of quickly. But to figure out why these are valid steps that we can make, why these are valid deductions, that takes a little bit more work to show that these are valid deductions that we can make, that it is valid to move from these premises to the conclusion. So we'd have to write down what exactly the rules of deduction that we used are to get from the premises to the conclusion. And we also have to cite the lines that we used to make those deductions to show that actually we can get from the premises to the conclusion using only information that we already have in the premises and our rules of deduction. And that's really important. In order to have a good argument, you need to be able to infer the conclusion from just the information that you have in the premises. Okay, so that's why we cite the rule of deduction to make sure that we're making a valid deduction. We know what our valid rules of deduction are. We have to make sure that we're using one of the ones that we know works. So we have to cite our rule, and we have to cite the line that we're using to show that not only did we use a valid rule, but we were able to make this deduction using only the information that we already had. Okay, that's what's going on. We're moving from the premises to the conclusion using valid deductions, and we are using only the information that we're already given in the premises. Okay, so this is great. I think that's all we need for just talking about what this is that we're doing, what's even going on here, what this is. So hopefully that's a little bit clearer. So now we have to talk about how it is that we figure out which rule of deduction which we're using. So that's what we're doing on the exam. In your homework assignment, you had to sometimes give me the rule, sometimes you had to give me the claim that you deduced, and sometimes you had to give me the line that you were citing. Now, on the exam, I'm only asking you for the rule itself, so you don't have to figure out the claim that you cite, and you don't have to figure out the line. I give those to you. So on the exam, you just need to figure out what the rule of deduction is. So we're going to go through the steps for how you would figure out what exactly fills out your sub-premise. And again, some of these steps are going to be a lot easier on the exam. So step one is to find the lines. So find the lines that are going to help you get from whatever information you already have in your proof to the line that you're on in your proof. So say we're on line 4. I'd want to find out and isolate the lines that I need to look at in order to deduce what's in line 4, which in this case is P. Okay, so find the lines. Again, that's going to be really easy for you on the exam because I give them to you. So that's great. This step, you can fly right through it. Here, I tell you that you need lines 2 and 3. So what we would do is say, okay, I'm going to look for what's in line 2, that's P or R. And I'm going to look at what's in line 3, that's not R. And I'm going to isolate those. I'm going to take those out and look at just those lines. And I'm going to say, how do those lines, the information in those lines, work together to give me P? How can I know, based just on the information there, that I can deduce P, or whatever's in my line 4? Okay, so you find your lines and you isolate those lines. You isolate the information in those lines. Step 2, you break it down. So what you want to do is make it as simple as possible. Sometimes lines, the lines that you're looking at can be really complex. So for example, in our second example that we'll look at, the first premise says, if not A, then B or C. Okay, that's a little bit complicated. There's a lot of variables there. There's a lot going on. So what we want to do to simplify it is look at what is the primary logical operator. In this case, the primary logical operator is a conditional claim. So there's a lot going on here, but in terms of step 2, in terms of figuring out what our rule of deduction is that we're using, all we really need to know is that we're looking at a simple conditional claim. Yeah, there's a lot of stuff going on here, but in the end, for what we're worried about right now, it's just a conditional claim. That's what we're concerned with. Okay, so we would break this down by first looking at what our primary logical operator is. Then we have to figure out what's up with the negation in this claim. Sometimes we are really concerned with the negation and we have to preserve it, and it's going to be really important to figuring out what the rule is. And sometimes negation can just be there to kind of complicate things and trick us. We'll talk about, okay, not trick us, so don't be stressed about that. But sometimes when you see negation, it's not really that important to focus on, and we can kind of gloss over it just to make things more simple, just to break things down more clearly. We'll talk about what cases, when that will be the case in a minute. So when you break it down, you want to look at what is your primary logical operator and what do you have to do with negation here. Again, that might sound a little bit weird right now, but we're going to talk about it and see that it's pretty easy to figure out when it's the case that we need to preserve negation and when we can be like, we don't really need to worry about negation in this situation. Okay, great. So our third step is just find the rule. So you've figured out what your lines are, You've broken it down into the simplest terms possible. You're looking at it as the simplest version of that type of claim. And now you just see, okay, which rule does this fit into? So which rule in my book does this look like? All right, those are our 3 steps. Again, find the lines, break it down, identify the rule. Now we're going to start with our example. So example 1, again, our first premise was if P then Q. Our second premise was P or R. And our third premise was not R. Our conclusion is Q. So now we have to see how can we get from these premises to the conclusion. What rules of deduction can we use to get from the premises to the conclusion? Okay, our first sub-premise, the first part that is the work that we're doing, is line 4, where we've indented it here. So line 4 tells us that the claim that we have in line 4 is P. So what we know is that we can infer P with just the information that we have in the lines above here. So we want to look at which lines it is that allows us to know that we can somehow infer P using just the information that we have in lines 2 and 3. So line 2 says P or R, and line 3 says not R. And we know, again, that with just the information in these 2 lines, we can infer the claim in line 4, the line that we're looking at. So we know that if we have P or R and not R, from that we can infer P. Okay, so we've found the lines that we're looking at. We're looking at lines 2 and 3, and of course, we're looking at the information in line 4. That's the line that we're on. Okay, so now we go to step 2, where we break it down into the simplest terms possible. So what's our primary logical operator in this line here? This was the information from line 2, so P or R. Our primary logical operator is a disjunction. So there's only one logical operator. That makes things easy, and it's a disjunction. Can we simplify this disjunction claim any further? No, that's as simple as it gets. This is a very simple disjunction claim. So we're off to a really good, nice, clean start here. Okay, so we have a simple disjunction claim. Great. Our next one, we have not R. So is this as simple as it gets? Yeah, this is also very simple. We have one logical operator, negation, and we have our variable R. Okay, and lastly, let's look at our last claim, P. Is that a simple claim? Yeah, that's literally as simple as it gets. There's no logical operator at all. It's just P. So that's awesome. We're all set there. We also have to look at what's up with the negation. Do we have to worry about negation here? I'll tell you in the next example of a situation in which negation might not be an issue that we really need to focus on. But here we know that negation is something that we have to preserve. It is something that's going to be important to us in identifying the rule of deduction that we're using. We know this because the only time that we have negation is in front of the variable R. And we also have another case where we have R, but it's not negated. So here we have R that's not negated and R that is negated. And because we have R in both of these forms, in the plain regular form and in the negated form, then we know that something's up with the negation. We know that we're kind of adding negation somewhere and that this is going to play an important role. Okay, so here, because we have R that is not negated and is negated, we have this difference in negation for R. We know that we've got to keep it and we've got to focus on that. Okay, so we're keeping negation. That means that now this is as simplified as it can possibly be. So now we open our book and we look through all of our 18 rules rules of deduction, and we see, okay, do any of these rules look like this? Maybe they have different variables, but in general, do we have any rules that look like this where we have a disjunction and one of its disjuncts is negated, and that allows us to infer that the other disjunct is true? We do. It's called disjunctive argument. So we know now that there's a rule that tells us that, yeah, if we have this information, like in lines 2 and 3, that we can infer the information in line 4. The rule is disjunctive argument. Now in the book, I think it uses different variables. I think that it uses P and Q, but the form is the same. So the reason we wanted to break it down into as simple of terms as possible is to make it easy to see where it's going to be in the book. The actual variables that the book uses are going to be different, but the rest of it's the same, where you have a disjunction claim, one of its disjuncts is false, and that allows you to infer that the other disjunct is true. Okay, so you can find the rule that looks exactly like this, even though the variables aren't exactly the same, but the form is the same. Okay, so that's the rule that we're using. And just to motivate this rule, you can think about this as saying, we're using a different example here to explain disjunctive argument. So, right, like in your book, I think it says P or Q, not P, therefore Q. This should be the example in your book. So let's say that P is it's Monday and Q is it's Tuesday. We say either it's Monday or it's Tuesday, and it's not Monday, therefore we can infer that it's Tuesday. So hopefully that makes a little bit of sense. When you have a disjunction and or claim, you say either one of these things is true or the other is true, and one of these things is false, then the other one has to be true. Okay, that's what disjunctive argument says. So that's the rule that we used here, disjunctive argument. We're doing great. Now we can move on to our next rule. So here we know that we're going to be able to infer Q from whatever the lines are that we're citing. So we can write Q first and say, we know that that's what we're going to be able to infer. So now let's look at the lines that give us the information that's going to let us make that deduction. Okay, so it says lines 1 and 4. So you have if P, then Q in line 1. In line 4, the claim that we have is P. So here we have if P, then Q, and P. And we're saying that with this information, we can deduce Q. So is there a rule in your book, a rule of deduction, that tells you that if you have a conditional claim and the antecedent is true, then you can automatically deduce that the consequent is true? Yeah, it's modus ponens. So that's a rule that we're familiar with. And it says that if we have a conditional claim and the antecedent, then we know we've also got the consequent. Okay, so that's how we can go through and figure out what our rule of deduction is. First, we figure out what's the information in the lines that we're citing, and we isolate that so that we're not worried about juggling all of this information over here. We're just focusing on the information that's important. So we look at the lines that we're citing, and we know that we can, with the information from those lines, deduce the claim in the line that we're on. And then we take that, we put it in its simplest terms possible to help us be able to really easily recognize that form in the book. And then we actually look for that form in the book. We look for the rule of deduction that has the claims with that same form. Okay, so that's how we do it. We're done with our first example. We can move a little bit more quickly through our second example. Okay, so here we just have two premises. Our first premise is, if not A, then B or C. And our second claim is not B or C. Oh, I'm sorry, there should be parentheses here. Okay, so our second premise is not B or C. And our conclusion is A. So we know that we can get from these premises to this conclusion using some rules of deduction. Now we need to figure out what those rules are. Okay, so the first claim that we know we can deduce somehow is not A. And let's isolate the information from the lines that we've cited that we know can give us not A. That's lines 1 and 2. So those are both of our premises. So one line would be if not A, then B or C. And the second line is not B, or C. Okay, so we have our lines, we have that information isolated, we have it pulled apart, and now we're going to break it down into the simplest terms possible. So let's start with the first, with our first premise. What's our primary logical operator here? It's the conditional claim. So the arrow, that's our primary logical operator. So it's the operator that's most outside of the parentheses. We also have a negation that's outside of the parentheses, but remember, negation works a little bit differently. So negation is only the primary logical operator if it's the most outside of the parentheses and it's the only logical operator outside of the parentheses. Okay, so this one, even though it is outside of the parentheses, it's not the only logical operator, and negation is always going to take a back seat to another logical operator. So here it's taking a back seat to the conditional. Conditional, primary logical operator in this claim. Okay, so our primary logical operator is a conditional. We have the arrow. Now there's a lot going on here. Our antecedent and our consequent are both pretty complicated. So we want to make sure that we're thinking about this in simple terms. I'm going to think about this as a simple conditional claim. Now it's important what this is, like what the content is of your antecedent and of your consequent, but in terms of trying to identify the rule, we want to focus on the form of the conditional claim itself. So we're saying that, yeah, there's a lot of stuff going on here, but what we're interested in is the fact that, in essence, this is the same as saying if P then Q. Just a simple conditional claim. Okay, and then here, our second claim is not B or C. Okay, so something that we notice already about not B or C is that it contains the consequent from our first claim. I'm just erasing the circle and rewriting the arrow so that it's easier to see what's going on. Okay, so here our consequent is B or C, and we recognize that here too. Okay, and we're trying to think about this in as simple of terms as possible. So we're saying here's a conditional claim, and we have the antecedent, we have the consequent, and then the consequent is negated in the next line. So we can think of this, you can say something like, this would be like saying if you had if P, then Q, and not Q. Okay, now I know that, hang with me, I know that the P here that I've written, as we're like simplifying this and trying to think about it in simple terms, this doesn't have a negation. This P is just representing not A. So this P is supposed to be in place for not A. This Q is supposed to be in place of B or C. Okay, we're just saying here we have the antecedent, and we have the consequent, and we have the negated consequent. So we have an antecedent, a consequent, and the negated consequent. And we know that it allows us to infer the negation of the antecedent because it says not A. The antecedent is not A, and we're getting the negation of the antecedent, which would be not A. Okay, so we have a conditional claim, the negation of the consequent, and we're saying that we can infer the negation of the antecedent. Now this is all very complicated. We can think about this in simple terms and say, okay, there's a lot going on here, but this is just like saying if you had if P then Q, not Q, therefore not P. Because again, we have, I'm going to rewrite this. We have our antecedent, we have our consequent, we have the negation of our consequent, and it says that we're getting the negation of our antecedent as our deduction. So this essentially takes the exact same form as this, as If P then Q, not Q, therefore not P. Okay, and is this look like any pattern of deduction in your book? Yeah, this is modus tollens. All right, so we have modus tollens. Now, we went through all those steps, and it seems a little complicated. But really, all we had to do was say, oh, you know what? This is a conditional claim, and here we have the consequent being negated, and we have the antecedent being negated. That's all we have to see here is this kind of a pattern. And we can say, okay, well, let's make that really simple, and we'll look for something, a really simplified version of that pattern in the book. Okay, so we found modus tollens, and this was modus tollens, allows us to make this, this deduction. All right, so now we can move on to our next line. Line 4 tells us that we can infer A from something in line 3. What's line 3? What's not A? Okay, so is there a rule in your book that tells you that that takes something like this pattern, where you have a variable that has a double negation, and it allows you to infer that same variable without any negation? Yes, double negation. It's called double negation, so that helps. That's an easy one to remember. Double negation tells you that whenever you have two negation signs, you can simplify that to no negation. If I say it's not Monday, that's like saying it's Monday. Okay, and that would also be the same if you had if you ended up with a really complicated some really complicated step where you had 3 negations, you can simplify that to just be 1 negation. So 2 negations cancel each other out. Okay. You will not see something with 3 negations on your exam. If you do come up with 3 negations somehow, then I'll just tell you now, you made a mistake. You got to back up and try it again, or send me an email and ask me what's going on. So that won't come up. If you see double negation, which you might, it would only be with these 2 negations signs being able to be simplified into 0 negation signs. Okay. All right, so that's it. Again, first you find the lines, you isolate whatever's in the lines that you're talking about. So those are the lines that you've cited and the claim in the line that you're on. Then you break it down into as simple terms as possible. You say, okay, there's a lot going on here, but what's the essence of this claim? Is it in essence just a conditional? Is it in its essence just a disjunction claim? And you have to make sure that you're doing the right thing with your negation, that you're preserving negation when you need to, and that you're not being distracted by negation when you don't need to. Be distracted by it when you don't need to preserve it. Okay, and in step 3, you're going to find and identify the rule. So if the thing that trips you up most is step 2, which I imagine it is because it can be the trickier part, don't worry, we're going to have practice with that on the problems from your homework. Okay, so that's it. We're going to talk about the homework problems next, but if you have any questions about this stuff before you go on to the next video, stop, send me an email, let me know, and we can figure it out.